All right, well, welcome everybody, and thank you for being here. My name is Jordi van den Brekel, and today I will teach you how you can steal money from someone's debit card while it's inside his wallet and still inside its pocket. So let's get started. Well, first I would like to tell you something about me. Well, as I said before, my name is Jordi van den Brekel. I'm from the Netherlands, and what I'm going to present to you today was part of my graduation project from last year. My graduation project was performed in collaboration with 2 universities. So first of all, the University of Technology in Eindhoven, and my supervisor there was Nicolaas Anoon. I also studied at the University of Nijmegen, the Radboud University, where I had 2 supervisors, Eric Pol and Juri de Ruiter. And I performed my graduation project at KPMG, where I also had 2 supervisors, namely Stan Hecht and Thijs Timmerman. And after my graduation project, I started working as an IT security consultant at KPMG starting this year. So what are we going to talk to you about today? Well, first of all, I will tell you all about EMV and what it is exactly. I'll tell you how a contactless transaction works. I will give you an introduction to relay attacks, and I will show you my proof of concept on the relay attack. I'll talk to you about the performance of the relay attack. We have some really interesting facts there. I'll also go into some of the limitations of the proof of concept, and of course, we'll finish with the conclusions. So we'll have 2 short videos today and also a live demonstration of the relay attack. So it's going to be really fun, I think. So let's start with what is EMV? Well, EMV is an abbreviation for Europay, MasterCard, and Visa, which are the 3 founding companies of EMV. And EMV, it's a company that owns the EMV specification, and the specification is about the protocols of how debit and credit cards communicate with the terminals. So actually, all of you will probably use it probably every day without even knowing it. So when you use the internet banking device, well, that's EMV. When you take money from an ATM machine, that also uses EMV. When you pay in a shop at the point of sale terminal, that's also EMV. And since a couple of years, we also have the Google Pay and the Google Wallet and Apple Pay, which also use the EMV specification. So today we will be mainly focusing on the contactless EMV. It has been introduced last year in the Netherlands. It's getting really popular. It's much faster than using the chip on your card, which is also known as pin and chip. So it's much faster. You don't have to use your PIN code if the amount is below 25 euros or $25. So it's a lot more convenient than sticking your card inside the ATM machine. So EMV is an international standard used mainly all over the world, so at least 130 countries. The specification is really extensive. It's documented in books, and the books consist of a total number of more than 2,000 pages. So it's really hard to get into it and to understand everything and all the features that are possible. Furthermore, it's really complexly written. And to give you an example, I put 1 sentence out of the book on the screen. I will just give you a few moments to see if you can understand it. So this is 1 sentence. So we have 4 if statements in 1 sentence with a couple of ands and thens and a not. So it's really difficult to understand the complete specification. So there actually is a method to determine how difficult a sentence is. It's called the Fleisch-Kincaid grade. And if we apply this to this sentence, you would need 26 years of US education before you can even understand the meaning of the sentence. So let's talk about the EMV contactless transactions and what happens. So mainly there are 3 parties involved. Of course, you have the contactless card, you have the point of sale terminal, and of course the bank who needs to approve the transaction. So the interesting thing about using EMV is that you use the chip that's inside the card. So this way, every transaction has dynamic information. So there's a crypto processor in the card that calculates and encrypts data so that the bank actually knows that the data is fresh, compared to when you use a magnetic stripe card. The data is always the same. So a magnetic stripe card can be easily cloned or easily copied, the chip cannot be copied because there's a secret key in, and the key is stored inside the secure element, and it's really difficult to extract the key from the secure element. So this key is also known by the bank. So it's a shared symmetric key scheme. So when the card enters the proximity of the reader, the protocol starts, and it begins with a handshaking and negotiation phase, where the terminal and the card start to agree on what protocol to use, and yeah, you know, the account number and things like that. So if everything is fine, the terminal will send a request to the card to please encrypt some of the transaction details, for example, the amount and the currency, the date. They need to be encrypted by the card. And the card then uses its secret key to create an application cryptogram, as it's called. So it's just an encryption of the transaction details. But the terminal cannot decrypt it because the terminal does not have the secret key. So the terminal actually forwards this cryptogram to the bank, which does have the secret key. So it can decrypt the application cryptogram, and it can verify if the details of the transaction are the same as the point of sale terminal claims they are. So the bank has three options then. It can either approve the transaction, it can reject the transaction, but it can also ask for another verification, for example, the PIN code. So if the transaction is below 25 euros or below $25, it will be approved. But if it's above that amount, an additional PIN code is needed. So the customer would enter its PIN code on the terminal, send to the bank, and then the bank can either approve or reject the transaction. So if the transaction succeeds, you will get a receipt, of course, from the terminal. And if you're really lucky, sometimes on the receipt, the application cryptogram is printed. It's fun for me to see, but actually it's quite useless for most people. So today we'll be focusing on the NFC communication, because the NFC communication is unencrypted for the most part, while the communication between the terminal and the bank, it goes over a trusted channel over the internet, so it's really hard to see what is going on there. But the NFC communication is completely plain text, so you can actually see what happens. You can inject messages, you can alter messages, you can do a lot. So let's talk about relay attacks. So in a normal circumstance, a customer goes to a shop, takes out the card from its wallet, places it close to the terminal, actually taps the terminal, and then he can make a payment. So when he's finished his payment, he'll probably put his card back in his wallet, and now there can be no payment anymore. So as an attacker, what you could do, you could take, for example, a mobile terminal like this, and you can hold it against the pocket of someone, and you can make a transaction. But as an attacker, you probably don't want to do this, because first of all, it's really hard to get a terminal. You have to have a registered company, and the money would go to your own account. So it's actually pretty easy to see who committed the fraud. So a much better approach for an attacker is to use the terminal in a store. So you can buy a gift card, an iTunes card, whatever. But you still want to use the card from the victim inside the pocket. So what you can do, you can take two Android devices, place one against the card in the pocket, the other one against the point of sale terminal. And of course, the devices need to be connected to each other, so you could use internet, Wi-Fi, Bluetooth, whatever. So in this setup, all the communication is relayed from the terminal to the Android device, to the other device, to the card, and back again. So if you do this sophisticated enough, the card won't know it is not communicating directly to the terminal, and the terminal will not know it's not directly communicating with the card. So I'll now show you a short video of what a relay attack would look like in real life.
Het betalen met een contactloze pas heeft veel voordelen. Kleine bedragen worden zonder pincode afgerekend en de pas hoeft niet eens uit de portemonnee gehaald te worden. Maar wordt het voor criminelen zo niet heel gemakkelijk om te betalen met uw pas? Het enige wat criminelen nodig hebben zijn 2 standaard telefoons en een speciaal ontwikkelde app. De telefoons worden door middel van internet met elkaar verbonden. Eén telefoon wordt vervolgens tegen de betaalautomaat gehouden. Deze telefoon stuurt de gegevens van de betaalautomaat door naar de andere telefoon. De handlanger heeft nu de tijd om op zoek te gaan naar zijn slachtoffer. Vaak kun je gemakkelijk zien waar de portemonnee zich bevindt. De handlanger houdt de telefoon nog geen halve seconde tegen de zak aan en de gegevens van de pas worden doorgestuurd via de andere telefoon naar de betaalautomaat. De betaling is nu volledig afgerond. Het geld is afgeschreven van de rekening van het slachtoffer en de crimineel verlaat de winkel met zijn zojuist gekochte spullen. Het slachtoffer heeft pas door dat hij bestolen is op het moment dat hij zijn afschrift ziet. Er kan op deze manier tot maximaal €50 contactloos betaald worden. Wanneer criminelen ook de pincode weten, kan er tot €2500 contactloos betaald worden. Criminelen hebben al veel ervaring met het plaatsen van bijna onzichtbare camera's bij betaalautomaten. Daarnaast gebeurt het ook dat criminelen over de schouder van de slachtoffer meekijken wanneer hij zijn pincode intoetst. De contactloze betaalautomaten en contactloze betaalpassen zouden aangepast moeten worden om dit soort fraude te voorkomen. Tot die tijd kun je zelf de kans verkleinen dat je slachtoffer wordt door je pas in een metalen portemonnee te bewaren en je pincode altijd af te schermen als je hem intoetst.
All right, so now I'm going to show you how it looks like when it's live performed. So this is a point-of-sale terminal I brought from the Netherlands with me. So I will start the payment soon. Furthermore, I have 2 Android devices. So this one is the card emulating device. So I will place this on the terminal. And the other device will be placed close to my bank card, which is inside my wallet. And I will place it here in my pocket so that you can all see it. So now I should connect devices with each other. I'll just make a 1-cent transaction for this purpose. So I'll place this device on the point-of-sale terminal and this to my pocket. And the transaction is complete. If everything goes well, we'll get a receipt soon. Yeah, there it is. So this way you can actually very easily steal money from your victim. So let me tell you something about the development of relay attacks, because relay attacks, of course, are not new. They're probably known since the 80s, somewhere around there. And they've actually been performed on EMV as well. So it started with the EMV contact. So you would have a malicious point-of-sale terminal connected to another card. So what you could do with this setup, you would give the fake point-of-sale terminal to your victim. You will enter its card, you will enter its PIN code, and that information is relayed to the card, and the card can then be placed inside a legitimate point-of-sale terminal in another shop probably, and you can, for example, buy diamonds or really expensive things with the card from the victim without him knowing it. So it has also been performed on the contactless EMV with special hardware, for example, that would like something like this. But of course, this is really difficult for anyone to create because you would need to have a lot of technical knowledge to create this. So it has also been performed on certain mobile devices. For example, this Nokia, which is really old. It used the secure element to perform NFC. And with some devices, you could unlock the secure element, so you could upload your own application to the NFC adapter. But if you do this, you can never lock the secure element again, so you would never be able to use it for legitimate purposes again. So you probably don't want to do that. And there's the last option to use a modified operating system, for example, Cyanogen. It does have options to emulate a contactless card with your Android device. We tried to do this, but it's not really stable. It was not really mature, the software, at least in my point of view. So it was not also not the preferred option. So what has changed now is that there now is an application for that. You can just download it from the Google Store if you would like, if it would be released, of course. So what has changed? Now, since last year, or maybe end 2013, you have Android 4.4. It's also known as KitKat, of course. And with Android 4.4, a function called host card emulation was introduced. And since Android 4.4, it's possible to use your Android device to emulate a contactless card. So before Android 4.4, you could only use your Android device to read a card. But since KitKat, you can actually use it to emulate a card. So these numbers are from February 2015. So probably it's somewhere around 45% uses Kit Kat, feels right, or Lollipop, of course. So what about the performance? Because you can imagine if you relay all the communication between the card and the terminal, you will get an extra delay in the transaction. And if the delay is too high, well, the terminal can probably notice that it's not communicating directly with the card. So in order to determine the performance, I of course had to acquire a couple of bank cards. So I opened a couple of accounts in the Netherlands, and I ended up with this nice collection of bank cards. So it turned out the average Dutch transaction takes between 330 milliseconds and about 640 milliseconds. So if you use the default relay setup, it takes about 3 times as long, maybe 4 times as long. And this is actually pretty comparable to the normal relay attacks that you saw with the specific NFC hardware. So we've put all the timings in a graph, which you can see here. And the green bars, they represent the normal direct transaction times, and the red bars represent the relay transaction times. So as you can see, it's actually much slower. So if you would manufacture a point-of-sale terminal, you would probably want to put the limit of time probably somewhere around here. And for the Visa cards, of course, maybe a little lower because the Visa cards are actually quite faster than the Maestro cards. So if you want to be really safe and you don't want to reject any legitimate transactions, you could also place the time limit here. So you can still reject all the relay transactions, but you would definitely want to place it somewhere between 1,000 milliseconds and 640 milliseconds. So it turned out the most popular Dutch terminal actually allowed transactions up to 52 seconds. So it's almost 100 times as much as an actual transaction takes. So it's pretty clear they didn't think about this kind of relay attack. But still, we wanted it to be faster because in the future they could, of course, make a new firmware that would implement this competitive time limit, so our relay attack wouldn't work anymore. So I hope you remember this picture because I showed it to you a couple of minutes ago. So now we'll be focusing on the NFC part, and we'll take a look on the more technical details on how the NFC transaction looks like. So it starts with the terminal. As soon as the card enters the proximity of the terminal will send this command to the card. It's called the select payment environment. And as a result, the card will send all its financial application IDs that it supports to the terminal. So every card supports a couple of applications. For example, in this example, this card supports a MasterCard application and the Maestro application. They have a specific unique ID, and they have a priority, and all those applications are sent to the terminal. Well, the terminal, of course, also has a table of applications that it supports. So in this case, the MasterCard would be the application with the highest priority, but it's not supported by our example point-of-sale terminal. So this transaction will be performed with the Maestro application. So the terminal then sends the application ID of Maestro to the card, so that the card knows what kind of transaction it will be performing. Well, and as an acknowledgement, the card sends, okay, I have selected this application. So the third step in the protocol is that the terminal asks for the processing options. So on the one hand, this notifies the card that it's actually going to perform a transaction instead of just selecting the transaction application. And the card returns 4 locations of records, so it does not actually contain any data. It just tells the terminal where it can find the actual data. So in our example, the card has 4 locations where the data is stored. So then the terminal asks for each record the specific data that is inside the record. So it repeats this step 4 times. And inside these records, for example, there is the account number, the expiration date, the default currency, default country, the static information like that. And as a final step, we've already seen it before, is the cryptogram generation. So the terminal asks the card to generate the cryptogram containing the specific transaction details, for example, the amount and the currency and the date. And the card then creates the cryptogram with a secret key and sends it back to the terminal. So basically, there are 5 steps in this protocol. And on the next slide, I will show you how this protocol will look like with a complete relay setup. So it's going to explode a little bit. but it's basically the same. We still have 5 transactions, 5 comments. So what you can see here is that it's the same comments, but then the terminal sends it to the relay device sends it to the mole device, and the mole device sends it to the card. So we try to optimize this and make this faster. So the first thing that we noticed is that these 4 results from the card are the same for every transaction. So what you could do is cache these results in the relay device, so they would not have to be relayed anymore to the mole device. Well, we used to have 8 network comments and responses, and now we only have 1. So you can imagine this is already a lot faster. So we also noticed that at the card side, on the left side of the picture, these commands do not have to be performed at the card in order for the card to be able to make a transaction. So you do not have to first ask which application are supported. You can simply just select the application that you know it will support, for example, the MySure application. And also the records containing the account number and the expiration date, you do not have to request them at the card side in order to perform a transaction. So you can just omit these comments. So the only thing missing is now a message between the relay device and the mole device indicating that it's going to perform a transaction. So we added this get ready signal from the relay device to the mole device so that the mole device knows it can actually start the transaction. So another thing we noticed is that there's a pretty aggressively configured power saving function in Android. And it exists in the network adapter. So we found out that this kicks in after 100 milliseconds of inactivity. The network adapter actually goes in some kind of sleep mode or inactivity mode. And in order to wake up from that, it will need another 40 milliseconds additional delay to be fully functional again. So we circumvent that with a keep alive function, as we call this. And it's this piece of code. And what it does, it just sends a line over the network adapter, and then this thread goes to sleep for 80 milliseconds. Well, it's an endless loop, so it keeps doing this. It's also an asynchronous task, so it doesn't interfere with the main activity on the application. So with this asynchronous task, we can bypass the power saving function in Android and actually make the transaction even faster. So this is the same picture that we've seen before. The power saving function, well, we benefited from at these 4 places, because as soon as the terminal sends the generate cryptogram to the relay device, well, it really needs to wait for a response. So any 40 milliseconds that you would gain here is actually in your benefit. And of course, the mole device is also in the inactivity state. So you would benefit from it 4 times. So you might think you would also benefit from here, but actually that's not the case, because on the right side, well, you've seen that the keep alive function is an asynchronous task. So the terminal does not have to wait for the mole device to respond. It can simply continue with its own program until the network adapter is ready to send the signal. And furthermore, as you can see, the left part of the picture is much simpler and much faster than the right side of the picture. So the card actually has to wait 80 milliseconds or more anyway for the generate cryptogram command. So it doesn't matter if there's an additional 80 milliseconds of network inactivity. So the total reduction of this step is 160 milliseconds. So there's one final small improvement that I want to show with you today. Let's have a small look at the generate cryptogram command as we've seen it before. It consists of 98 bytes, and this is all the data that is stored in it. So as you can see, of course, the amount, the country, the verification, it should be a success, the currency is stored, the date. But as you can see, this data is actually quite predictable. So if you would agree with your attacker that you would buy an iTunes card of 25 euros, you already know the amount. The country code is known, of course. The currency is known. The date is known. Actually, everything is known except for the unpredictable number. The unpredictable number is a random generated number by the terminal in order to keep the transaction fresh. So these are the only 8 bytes that you cannot know before you start the transaction, because they are generated during the transaction by the terminal. So what I did is just send only 8 bytes, unpredictable number, instead of the 98 bytes of the full generate cryptogram command. So you can imagine this is not a really significant improvement of the protocol, but it actually reduces the time with another 3 milliseconds. So to conclude our improvements, this was the original protocol of the relay, and we have simplified it to this. So this is the complete relay protocol that we use. So now let's have a look at the performance again and how the performance is. So again, the green bars show the direct transactions, the red bars show the simple relay transactions as we've seen before. And now we also have the orange bars, which represent the optimized relay transaction times. So if you would place a time limit now on the slowest card, the first generation ABN card, you can actually see that all the relay transactions are faster than a direct transaction with the first generation ABN card. So there's no way you can ever make a competitive time limit on the terminal in order to detect the relay attacks. So for the Visa card, you would place it here, so you would actually be able to make a competitive time limit for Visa cards. They're not really used in the Netherlands, so for the Netherlands, it doesn't really matter, but for some other countries, it might be pretty useful. So one other interesting thing that we see is that with the first generation ABN card, the relay transaction is actually a little bit faster than a direct transaction with the card. And as far as I know, this is the world's first relay transaction that is actually faster than a direct transaction with the card. So what about the limitations of our setup? Well, the biggest limitation is that you can make transactions up to 25 euros or $25 without the PIN code. And you can do this twice a day, so in total you can only steal 50 euros or $50 from a card every day. Well, it could be interesting for some people, but it's definitely not interesting for career criminals because it's simply not enough for them. However, if you do know the PIN code, you can make up to 2,500 euros, and for some banks even up to 5,000 euros or $5,000, you can make a contactless transaction. So then it does get interesting for career criminals. So what they can do, they can use cameras to see your PIN code, for example, and they've got really sophisticated with this. For example, in this picture, there's a camera hidden. Can anybody see the camera, maybe? It's actually quite impossible to see, because it's placed here. And if we open this ATM machine, they actually used a really simple mobile phone with a camera attached to it. So there's actually no way of knowing that there was a camera in this picture. So what criminals sometimes also do is attach a fake PIN pad over the original PIN pad that just stores the key presses that you make. And if you make this sophisticated enough, you will never see that it's a fake PIN pad terminal. Of course, you can also use shoulder surfing. Just stand real close to someone who enters this PIN code, and you can actually see what the PIN code is entered. It's just a 4-digit number. It's not too difficult to see most of the times. And it might also be possible to use infrared to see the pictures. And how that will look like is shown in this video. It showed up last year. It's been viewed over 14 million times, so it's really popular. Well, it's a long video, 4 minutes. I compiled it a bit to make it a bit shorter, so I will show to you what it looks like.
So she just swiped her ATM card and she's inputting the PIN here, which is the last thing you do before you finish your transaction. And then I step up to make my purchase. So that was it. If you missed it, let me play that last part over again. And you'll see as I walk up, my phone just briefly hovers over the keypad. So let me explain what just happened. And as you probably guessed by now, your fingers leave a thermal signature when you type your PIN code into a debit card machine like this. And as you can see, in this case, the PIN code was 12345.
Wow, that's pretty interesting, right? If we can actually do this, it's really easy to steal someone's PIN code. So, this was the video slide. So in order to test this, we bought this camera, the infrared camera. It's an attachment for your mobile phone. And I will show you how it works. All right. just need a moment to start up. I'm not sure why it's taking this long. Ah, there it is. All right. So this is what you look like. So let's have a look at how it looks like if I enter my PIN code in this terminal, for example. So you can see this is the terminal. Put my hand over it. So if I zoom in, the colors get a little bit adjusted. So let me enter my PIN for you. So as you can see, or actually as you cannot see, this totally does not work. So we verified this with a couple of other terminals. Let me just get my screen correct. Yeah. So this is another terminal that we saw. On the left side, we entered 1, 2, 3, 4, 5. On the right side, we entered 6, 7, 8, 9, 0. Well, as you can see, it's completely impossible to tell which PIN has been entered. So how is that possible, and what did we see on this video? Well, if you take a close look, you can see that the 5 numbers entered, they're actually warmer than the point-of-sale terminal, which is what you would expect because your fingers are warm and the terminal is probably colder than your fingers. What you can also see is that the environment of the terminal on the right bottom and on the left bottom, the environment is much warmer than the terminal. And that is something that you would not expect, because if the terminal, it's in the environment, so it should have probably the same temperature. So my best guess is what they did. They put the terminal inside a refrigerator, take it out, then enter their PIN. And because there's a big temperature difference between the fingers and the terminal that has just been put out of the refrigerator, you can actually see the PIN codes that has been entered. But if the terminal is operating in a normal condition, it's heating up from itself, it's dissipating power, I don't think there's any way you can actually see the PIN code that has been entered. So what about the amounts? Well, first let's have a talk about the EMV contact amount. So this is the kind of transactions where you insert your card in the terminal and it uses the contact chip on the card. So it's not possible to make a transaction without your PIN code. For every transaction, no matter how small, you must enter your PIN code. And the maximum transaction is up to 2,500 euros, and in some cases even 5,000 euros or $5,000, of course. So this might be weird, because every transaction is protected with a PIN code, while your PIN code is worth up to 5,000 euros. So if I make a transaction of 1 cent, it's probably more secure to just approve the transaction without me entering the PIN code. Because every time I enter my PIN code on a machine, it's another opportunity for an attacker to actually see my PIN code over the shoulder, to record it with a camera, or maybe use an infrared camera, but that's not really likely. So it's probably more secure to just allow transactions up to 25 euros without a PIN code, because you can also do that with a contactless card. So if I lose my card, an attacker can steal 25 euros anyway. So why would you not allow pinless transactions with the contact interface? So another interesting thing that we see here is that you can actually pay up to 5,000 euros with a contactless card, which doesn't really make sense to me either, because if I want to buy a second-hand card, for example, 5,000 euros, well, I really wouldn't mind putting my card inside the terminal instead of paying contactless. You know, contactless, it's supposed to be fast, and it is, but it's mainly for small transactions. And why would you ever want to pay 5,000 euros contactless? It doesn't make much sense. So I actually think that these amounts are not optimized, and they should probably be optimized. So another thing that banks can do is check the geolocations of the transactions. Because as we saw before, a transaction can take up to 52 seconds. Well, that's probably enough to use a card in the Netherlands and to pay with it here in Singapore. So we have the situation in the Netherlands that if you leave Europe, you have to register with the bank, because your card is by default deactivated outside of Europe. This is to prevent fraud, of course, but if you travel outside of Europe, you have to notify your bank that you will be going outside of Europe, and they can temporarily activate your card for use outside of Europe. So when I came to Singapore, I of course did this because I want to use my card here. But nonetheless, after 2 days in Singapore, I received this text message from my bank, and I realize I'm the only Dutch-speaking person here, so I will translate this for you. Dearest customer, your card with number 283 has been deactivated by us because we suspect abuse. Please contact us at this number. So I called them to check what happened because I notified them I was going to be at Singapore, so they actually activated my card for use outside of Europe, but still it got deactivated. So it turned out there were some suspicious activity with my card, and mainly these 2 transactions. So the upper transaction is a transaction I made at an ATM machine. I requested 100 Singaporean dollars. And the lowest transaction is a transaction I made with my terminal, just to test if it works in Singapore. But the terminal is actually registered to a company in Rotterdam, which is a city in the Netherlands. So what my bank saw is that within 6 hours, I made a transaction both in Rotterdam and in Singapore. Well, the flight time is over 13 hours, so this is indeed quite suspicious. So I called the customer support, and I had to explain everything, and I don't think they really understood why I would bring my own terminal from the Netherlands to Singapore in order to perform a 1-cent transaction. But nonetheless, they believed me, and they actually reactivated my card again. So as you can see, they do check the geolocations. But in this case, I made the transactions on the 21st of March, and the 23rd of March, my cards get deactivated. So this tells us that they do check it, but the checks are reactive. So you can abuse a card for 2 days, and then they will deactivate your card. So it's definitely not preventive. So what they could have done otherwise, I made the transaction supposedly in Rotterdam at 11:30, and then at 7:30 in the evening, I tried to make the transaction in Singapore. So they could actually just reject the transaction on the fly, because there's no way I'm going to travel in 6 hours from Rotterdam to Singapore, of course. So as a conclusion, what have we learned today? Well, it's actually pretty simple to make a relay setup with 2 default Android devices. The only thing you need is 2 Android devices with Android 4.4 or Android KitKat. Well, I made an application. I took longer than 2 days because I had to invent everything, but now you have learned everything, so you probably would need approximately 2 days of developing with all the details that I've given you in order to recreate this application. So there is no effective countermeasure against relay attacks. And as you think of it, it's probably really difficult to realize it, because relay transactions are faster than the direct transactions, and timing is actually the only really effective countermeasure against a relay attack. So what the banks could do, and what the terminal manufacturers could do, they could make a check in the terminal to see if it's really a card that it's communicating with, because there are some difference between an Android device that's sending NFC signals and a contactless card that is sending NFC signals, of course. But they don't do this, and probably if you want to make the attack more sophisticated, you can also make the Android device really acting like a contactless card with sending a different unique identifier that is specifically used for contactless cards. So it's probably really difficult to realize. And as we have seen before, the payment limits are not that optimized. Every transaction with a contact chip, you have to enter your PIN code, even it's a 1-cent transaction or a €1 transaction. And every time you do that is an opportunity for an hacker to learn for an attacker to learn your PIN code. And also the €5,000 or $5,000 limit for the contactless card it just doesn't make sense to me. So I want to thank you for your attention all. And that was it. Can I take some of your questions, please? Yes? Yep. 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 Well, we have this. Well, in the Netherlands, we don't have offline transactions. So all transactions must be online, and we have a really great internet infrastructure in the Netherlands, so that's actually not a problem. We have internet everywhere. So the banks decided they would simply reject all offline transactions. No, I know, but yeah, of course, online transactions are slower, definitely. But they're also more secure, and the Dutch banks decided to only allow online transactions. Yes? I'm sorry, could you repeat that? Well, at this moment, I'm using a wireless access point that I brought myself. But you can use the internet. You can use direct Wi-Fi. It doesn't matter. Well, no, there's no detection of that. No, you just need to react within 52 seconds. That's the only constraint that you have, and that's really easy to do. No. I'm sorry, could you repeat? Well, it's more difficult if you have one card in your wallet. Yes, that's definitely true. So on some occasions, we did succeed with performing a transaction if there are two cards in the wallet. But if there's more than two contactless cards in the wallet, it's definitely really difficult to do this, at least with Android devices. I think if you use a more sophisticated NFC device, it will probably be possible to select the right cards from a stack of contactless cards. And of course, you also have, as I said before, you have these metal wallets. If your contactless card is inside a metal wallet, there's no way you can ever read it contactlessly, of course. Yes? Yeah. Yeah, you have all sort of creative solutions. You have a card with a light sensor. So it actually needs to be placed outside of your wallet to be activated by the light. You have a pressure that you have to press. You have biometric fingerprint. Yeah, they're getting really creative. But of course, this is all really expensive. And a card should be as cheap as possible for a bank. So as long as this is not abused on a large scale, they probably won't give you a biometric card. No. Any other questions? Okay, well, if you think of any other questions, you can also email me. The email address is at the bottom of the screen. So I want to thank you again. It's been great today. Thank you very much.